So now we're going to look into the most important and most misunderstood concept. So and very interesting concept too. And so looking at these subtle differences are very important. So that is a Docker as a lightweight virtual machine. So virtual machines have become ubiquitous in software development and deployment. Since the turn of the century, the abstraction of machines to software has made the movement and control of software and services in the internet age easier and cheaper. So virtual machine is an application that emulates a computer, usually to run an operating system and applications. It can be placed on any physical resources that are available. The end user experiences the software as though it were on a physical machine, but those managing the hardware can focus on large scale resource allocation. So, whereas Docker isn't a VM technology, a virtual machine technology. It does not simulate a machine's hardware, and it does not include an operating system. A Docker container is not by default constrained to specific hardware limits. If Docker virtualizes anything, it virtualizes the environment in which services are run, not the machine. So, moreover, Docker can't easily run Windows software or even that written for other Unix derived operating systems. From some standpoints, though Docker can be used much as VM for developers and testers in the internet age, the fact that there is no init process or direct hardware interaction is not usually of great significance in Docker container. And there are significant commonalities such as its isolation from the surrounding hardware and its amenability to more fine grained approaches to software delivery. Now, what are those subtle differences between VMs and Docker containers? That's virtual machines and Docker containers. Docker container or Docker is application oriented, whereas VMs are operating system oriented, that is OS oriented. And Docker containers share an operating system with other Docker containers. In contrast, VMs each have their own operating system managed by a hypervisor. For Windows, example is Oracle VMware or virtual VM VirtualBox. Then Docker containers are designed to run one principal process, not manage multiple sets of processes. So let's see this example, the container slimming process. You will the route taken and the got tar, you got the tar any package, and then so you have made an image using the tar has been included in your image, and after that you want to do some slimming process, you want to strip the image. Then after the stripping the image, you have exported that image back, and so image cannot be stripped more or is small enough. It depends upon whatever you want, you can do it. Then you can use that slimmed image to save money. So that's the benefit of a container, whereas that's not possible a with a virtual machine or VM. So the image can be slimmed. The image can be modified based on the requirements so that you can save huge amount of money. So now let's go back in time and we will see each type of deployment to get the clear cut understanding and to get the understanding of subtle differences between each and every one that are present in operations or deployment at this moment. So the first one is our traditional deployment or traditional era. Early on, organizations has run applications on physical servers. There was no way to define resource boundaries for applications in a physical server, and this caused resource allocation issues. For example, if multiple applications run on a physical server, there can be instances where one application would take up most of the resources, and as a result, the other applications would underperform. A solution for this would be to run each application on a different physical server. But this did not scale as resources were underutilized and it was expensive for organizations to maintain many physical server. So what we can do? Then came a virtualized deployment era. As a solution, virtualization was introduced. It allows you to run a multiple virtual machines on a single physical server CPU. So virtualization allows applications to be isolated between VMs and provides a level of security as the information of one application cannot be freely accessed by another application. Virtualization allows better utilization of resources in a physical server and allows better scalability because an application can be added or updated easily but reduces hardware costs. So each VM is full of machine running all the components including its own operating system on top of the virtualized hardware. So with virtualization you can present a set of physical resources as a cluster of disposable virtual machines. So then came our container deployment, the new era, the era of containers. Containers are similar to VMs, but they have relaxed isolation properties to share the operating system OS among the applications. Therefore, containers are considered lightweight, similar to a VM. Container as its own file system, share of CPU, memory, process space, and more. As they are decoupled from the underlying infrastructure, they are portable across clouds and OS distributions. If you see at the all three images on your screen, traditional deployment is like deploying an application and running the services directly in your mainframe. And for the virtualized deployment, you take your mainframe. Inside that, you have used an hypervisor software and operating system voice remains same. You have installed hypervisor software and then you have virtualized your mainframe into different machines. So you will have a virtual machine and each virtual machine can have a separate OS operating system and bin library, and in each virtual machine again you can deploy lot of applications and lot of services. And the third one is container deployment. Here So as it is, your mainframe and operating system remains same, but instead of hypervisor, here we can use a container runtime such as Docker. Docker is one type, one such type. You can use anything else. So container runtime, and this is going to build n number of containers which are slimmer than virtual machine, which are lighter than virtual machine, and you can use n number of containers, and each container can have one app, potentially one application and few one service inside that, and each container will consist of a bin and library files and file system and CPU, memory, process space. It's gonna share CPU, it's gonna share memory of mainframe, it's gonna share process space and much more. But it is not going to have its own OS. It's going to share the OS of the mainframe. Or another way of doing is, you have a mainframe, hardware is our mainframe and operating system. On top of that, you install a hypervisor and you convert your mainframe into 10 to 15 virtual machine. And inside that virtual machine, you can again install container runtime, that's a Docker, and then you can create n number of container for n number of applications. That is one way of doing. So all the end point, the end result, or end goal to do all those things is to money save money and increase the efficiency of the running services, increase the efficiency of the deployment, increase the efficiency of providing an application to the external user on web. www